Hey, so carrying on with our complex numbers, in this episode we're going to be looking at how to find roots of z raised to the n. So if we've got z in terms of a plus ib, then our z with subscript l, so each of our roots of z, where l increments 1, 2, 3, 4 all the way up to the same as n. So if z was raised to the 50, we'd have 50 roots of z, say. This is equal to the magnitude of our z to the n raised to the power 1 over n by our exponential e raised to I, and then all of this term here, which includes an argument, plus k, where k increments from 0 all the way up to 1 less than n, by tau, which is also equal to 2 pi, and all of this is over n. It looks like quite a complicated little formula, but you get it relatively easily. So we've got ourselves a problem here, and we have that z to the 6 is equal to 5 plus I5. There was a bit more to this problem, getting to that, but we've got rid of that stage because there's no point. That's all just multiplication stuff. So the first thing we need then is our magnitude, or modulus as some people call it, of z. So we square both of these and square root it, add them together, square them, add them and square root it, so we get root 50. And then also we need our argument. Now these are both equal and it's in our first zone, so we're going to have a normal 45 degrees. 45 degrees is a quarter pi or 1/8 tau, but we use a quarter pi for all of this. Now we can see by looking at this that the first part of this doesn't increment with any value k for each of the roots, so this is always the same, this is always constant. So what we can do is we can say then that the magnitude part of our z to the l, which is the bit that's going to always go here, is equal to root 50 all raised to 1 over 6 in this case, which is equal to 50 by 1 over 12. Raised to 1 over 12, sorry. So that's that bit dealt with. That's this part, nice and easy. Now we get to the harder bit. So we'll just deal with our e to the I term for a start. And we'll have our e to the I. And now we have our argument, which is 1/4 pi plus k. Now k 2 pi. And this is all over 6. So we can now see that this is going to be equal to e to the I, and 1/6 of 1/4 is 1/24, so 1 over 24 pi plus k. Now k we're going to get 1/3 pi. Now that doesn't make life very easy, because we've got a 1/24 and 1/3. So what we might want to do here is to multiply both the top and the bottom by 8, so that we can actually have the e part to this is going to be to the I 1 over 24 pi plus k 8 over 24 pi. Okay, so what I'm going to do is I'm going to go through and do the first root. So if we do z to the 1, this is going to equal, so 50 for 1 over 12 e to the I. Now k in the first one is 0, so it's just 1 over 24 pi. Then for each of the other ones, just keep adding 8 over 24 pi to this each time, until eventually what will happen is you'll get to z to the 7. Okay? And now we know there's only 6 roots, so why am I going for z to the 7? When we see z to the 7, you'll find it to be 50, 1 over 1/12, e to the I, and then it's going to be 49 over 24 pi. Now if we just expand this little bit here, we see that 49 over 24 pi is actually equal to 1 over 24 plus 2 pi. So pi over 24, sorry, plus 2 pi, which is actually the same as 1 over 24 pi. So when you get to z to the 7, you see that z to the 7 is actually going to be equal to z to the 1 at that point. So you've just looped all the way around. And you'll see what I mean now. So I've wrote out all of the separate roots just there. Each of them incrementing with a 8 over 24 pi, so we get to z to the 6. And if you were asked to draw an Argon diagram, you see I've sketched out a circle here to show that all of the magnitudes are equal. We have angles phi and all of these gaps between each one, where 6 phi equals 2 pi. So all of these spacings are equal. Their magnitudes are all equal. We're starting at 1 over 24 pi and going all the way around. And if you went from z to the 7, z to the 6, sorry, to z to the 7, you get back to z to the 1, which is why z to the 7 doesn't exist. That's basically how we find all the roots of a complex number. If you want to see the last video in the series, the next video in the series, or more from my channel, just go ahead and click there now.